So to help you pass the geometry exam, I'm going to explain the top 10 topics that appear on your Common Core geometry exam. So the 10 topics are transformations, similarity, trig, circle theorems, congruence or similarity proofs, equation of a circle, partitioning a line segment, density modeling or volume, coordinate geometry proofs, and then constructions. So in each of these, there's 2 problems. I'll do the first one, I'll let you do the second one, and then the answer key is on Schoology so you can check your work. Topic 1 is transformation. So a couple things to remember is rigid motions are reflections, rotations, and translations. They form congruent figures since they preserve side lengths and angle measures. If figures are congruent, they're also similar. And remember, your one transformation that is not a rigid motion is dilation. So in the diagram below, a sequence of rigid motions maps A, B, C, D onto J, K, L, M. So again, my letters change, which I'm going to highlight what corresponds with what right away. So A is the first letter there, so J corresponds to it. So I'm going to highlight A and J. Next is B and K. Next is C and L. And then finally is D and M. So those are my corresponding angles. So remember, rigid motions have congruent figures, which means those angles are congruent. So it says if the measure of angle A is 82, measure of angle B is 104, and measure of angle L is 121, the measure of angle M is blank. So first I'm going to label. Angle A is 82, angle B is 104, and angle L is 121. However, I know I'm trying to find angle M. In addition, I know that corresponding angles are congruent. So angle J is also 82. Angle K is 104. I see JKLM is a quadrilateral, which means it has 4 sides. Therefore, I know that it adds up to 360. So what I can do is I can take all 4 angles and set it equal to 360. So when I do that in my calculator, I would get x plus 307 equals 360. Therefore, x has to be 53. But remember, we're trying to find the measure of angle M, so I have to write the measure of angle M is 53 degrees. And that would be my answer. So transformations, remember what rigid motions are, how to explain them, and then I would go over your transformation rules too. So you're going to try the next one. Topic 2 is similarity. So similarity usually has overlapping triangles. Remember, similar figures can be similar by side, 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 angle, side, and angle, angle. So you should always highlight your corresponding sides and corresponding angles. When you're using, say, no to Oreos, so that new over original, mark what your new and original triangles are. Set up that proportion by using your corresponding sides that you highlighted. So you should never have like purple over yellow equals yellow over purple. It's got to be the same color over each other. If your triangles are overlapping, you should separate them. This makes it 100 times simpler to do the problem. So first one says, in triangle SCU shown below, points T and O are on SU and CU respectively. Segment OT is drawn, so angle C is congruent to angle OTU. So angle C is congruent to OTU, that angle. So right away I know these triangles are kind of flipped. I see that angle U is in both triangles, so my small one and my big one, so I know that's reflexive. So I'm going to redraw these triangles so that they're facing the same way, meaning that angle C is down here, and then my reflexive angle is on the right side. So for this smaller triangle, I'm going to have to flip it, so U's up here and T's down here. an angle used in that same spot. So it says TU is 4, so I'm going to mark it in my original diagram and in my new one. It says OU is 5, and then O to C is 7. So O to C is not in a triangle, but I noticed from C to U that would be 12. So C to U is 12. It wants to know what the length of ST is. So S to T is not in a full triangle, meaning I'm going to have to find SU first in order to get ST. So remember, you add those. So this would be X plus 4. So I'm going to highlight my corresponding sides. So I know that one goes with this one. And this one goes with this one. And now I'm going to set up my new over original. So I'm going to pick my yellow side first. So my yellow side is 12. My corresponding yellow side is 4. Then I'm going to go over to red. So in my new triangle, it's X plus 4. In my original triangle, it is 5. So I got red over red here. And then I got yellow over yellow here. So make sure your proportions look something like that. So now I can cross multiply. But before I try to do it in my head, I'm going to write it out. So this is going to be X plus 4 times 4 equals 12 times 5. If you write it out, that's going to help you. So what you remember, you have to distribute here. So this would be 4x plus 16 equals 60. Now I'm going to subtract 16 over. I get 4x equals 44. Divide both sides by 44, and I would get x equals 11. And then remember, we're solving for ST, so ST equals 11. The next one, there's 3 right triangles. Whenever I see 3 right triangles, it's left, right, whole. So I'll let you separate it and try it, and then you can check your answer. Topic 3 is trig. So make sure you label the sides of your triangle with opposite, adjacent, and hypotenuse. We're going to use SOHCAHTOA. When solving for a side, always cross multiply. When solving for an angle, you hit second in your calculator, then your trig function. So the first one says, in right triangle, sine 40 minus x equals cosine 3x. So I know it's a right triangle. Remember, the sine of one angle equals the cosine of the other angle. However, we're talking about these two angles in a right triangle. So remember, those two angles always add up to 90. Therefore, to solve for x, I'm going to do 40 minus x plus 3x equals 90. So those angles aren't equal to each other. They add up to 90. Now I'm going to combine like terms. So I get 40 plus 2x equals 90. Subtract 40 over. I would get 50. Divide by 2, and I would get 25. So explain why this is equal to 90. It's because sine and cosine are, now remember this word, cofunctions. So that means their angles must add up to 90. So there's always one question involving cofunctions on your exam. So try to remember that. The next one is a double triangle question. So they like to give you these on parts 3 or 4. So separate your overlapping right triangles only, and then use SOHCAHTOA to solve for x. So again, that answer will be on Schoology. Topic 4 is your circle theorem. So just a reminder, area of a sector is A equals n over 360 pi r squared. Arc length is AL equals n over 360 2 pi r, or AL equals n over 360 pi d. Some theorems you gotta keep in mind is congruent chords have congruent arcs. Arcs between parallel chords are congruent. Inscribe angles that open up to the same intercepted arc are congruent. If you have an inscribed quadrilateral, opposite angles are supplementary. And then you in addition, need to remember all your formulas for angles and segments in a circle or outside a circle. So I'm going to do one with you, and then I'm going to have you try the next one. So this one says the area of a sector of a circle with a radius measuring 15 centimeters is 75 pi. So right away I see area of a sector. So I'm going to write down my formula. A equals n over 360 pi r squared. It wants to know what the measure of the central angle is. So in my formula, remember your angle is always n. So I'm going to put x there so I know that's what I'm solving for. That means I got to plug in a and r. So it says the radius is 15. So this would be 15 squared. R is 75 pi. Now I just got to solve for x. So when you have pi on both sides, they cancel. So I'm left with 75 equals, now 15 squared is 225. So remember, whatever number's there, you're going to place on top of the fraction with x. This way I can put 75 over 1 and cross multiply. So again, I'm going to write it out before I do it. So 225x times 1 equals 75 times 360. So 225 times, or 225x times 1 is just 225x. 75 times 360 is 27,000. Now to get x alone, I divide both sides by 225, so my answer is 120 degrees. So again, try the next problem. Topic 5 is your proofs. So a couple things. If you're trying to prove triangles are congruent, you use side, 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 angle, 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 side, or HL. Once you've proven triangles are congruent, then you can use CP/CTC if you're trying to prove angles or sides are congruent. In addition, they might ask you similar triangles. So ways to prove two triangles are similar is side, 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 and side, and angle, angle. When you don't know the reason, let's say you're just forgetting what to write for reasons, don't be afraid to write definition of blank. So fill in the blank with a vocab word that was either in your given or you can see it in your diagram. So if I saw like AB bisects angle ABC and I forget why angle 1 and 2 is congruent, I would write definition of angle bisector because in my given I saw bisects. So don't be afraid to use that if you don't know what to write. So in this first one it says, in right triangle ABC shown below, altitude CD is drawn to hypotenuse AB. Explain why these two triangles are similar. So the two triangles it wants me to look at is ABC and ADC. So right away I notice that my red and my yellow overlap at angle A. So I know angle A is in both triangles. So I'm going to write a sentence on angle A. So angle A is in both triangles. So it has to be equal to each other. And that's called the reflexive property. I wasn't given any side lengths, so that's why I can't do side, 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 or side, angle, side. So I'm going to prove this similar by angle, angle. So we got one angle out of the way. Next, I'm going to take a little hint at these words up here. So altitude CD and hypotenuse AB. Altitude is a perpendicular line, and hypotenuse is always across from a right angle. So remember, altitude's telling you there's a right angle, hypotenuse is telling you there's a right angle. So there's a right angle at C, I'm going to call that angle 1, and there's a right angle down here because it's an altitude. So I'm going to call that angle 2. So now we just got to write that out in words. So angle 1 is 90 degrees since AB is a hypotenuse. And angle 2 is 90 degrees since CD is an altitude. So angle 1 is congruent to angle 2 because they are both 90. Therefore, these two triangles are similar by angle, angle. So I just wrote this out in a paragraph. You could have done statements and reasons. I just found it was easier just to write it out because you just had to mention your reflexive angle and then your 90-degree angles. So I'll stop it right here, and then the next video you can watch topic 6 through 10.